Good morning, good afternoon, good evening, all of you. Thank you very much for joining this Breakout Group 2, the current landscape of renewable energy technology and application and its impact on conservation and sustainable use of biodiversity. My name is Osamu Saito. I'm a principal policy researcher at the Institute for Global Environmental Strategy, IGES. So the key question for this session is, I prepared 3 key questions: how different renewable energy technology can drive ecosystem change and contribute to the biodiversity conservation and ecological restoration as nature-based solution, NBS. The second question is, how can we promote sustainable energy transition without losing biodiversity and producing negative social impacts? Third question is how the policy and projects of renewable energy and NBS can be operationalized and implemented to achieve target of the Global Biodiversity Framework and Sustainable Development Goals. So these are 3 kind of broad questions for this session. With this time constraint, we may not be able to fully answer these questions, but we would like to provide some interesting or important insights to respond these key questions. So these are 3 speakers I kind of invited for this particular session. The first speaker is Dr. Alexandros Gasparatos from University of Tokyo Institute of Future Initiative. Now he's joined, so we don't need to change the order. And then followed by the Dr. Amanda, the Tokyo Institute of Technology. She will discuss on the digital innovation in wood biomass supply chain in Japan, University of Bergen. He would present on the environmental governance and energy infrastructure. So let me invite the first speaker, Dr. Gasparatos, who will talk on the renewable energy and biodiversity implication on achieving post-2020 global biodiversity frameworks. So floor is yours, Alex.
Thank you very much for giving me the opportunity to speak here. What I would like to talk today is the interface between renewable energy and biodiversity, and what are the implications for achieving the post-2020 Global Biodiversity Framework. I think all of us in this event most likely agree that climate change is one of the major threats to biodiversity, but also that biodiversity through the ecosystem services it supports contributes to climate change mitigation and adaptation. At the same time, there is little discontent, I think, to say that renewable energy is one of the more promising strategies to massively cut carbon emissions and help mitigate climate change, which will likely have very big benefits to biodiversity. But also there is mounting evidence that there are some context-specific trade-offs, considering that renewable energy installations and killer infrastructure and upstream and downstream activities could affect biodiversity through multiple mechanisms. I have done quite several literature reviews on the subject, and there is a mounting evidence that renewable energy value chains have some sort of impact on biodiversity across the entire value chain, starting from mining mining and material sourcing for renewable energy infrastructure, to renewable energy generation and use, and decommissioning and disposal. Most of the evidence, and we have strong evidence for pretty much every renewable energy pathway, that there are very context-specific mechanisms through which renewable energy generation and use affects biodiversity. We create now, there are a few publications, especially last years, that they're touching on the issues of biodiversity impacts of material sourcing for renewable energy installations. But what we are lacking almost totally is evidence about what are the impacts of decommissioning and disposal. Most of this infrastructure is quite new. It's still operational. We do not know what might be happening when these things are being decommissioned, or maybe how to decommission them to reduce our biodiversity benefits. In my opinion, these trade-offs are because of scale mismatches. On the one hand, the intended benefits of increased renewable energy production mostly manifest at the national and the global levels. So we're talking about benefits like improved energy security, green job generation, or climate change mitigation, as I mentioned earlier, while some of the negative effects mostly manifest at the local and the regional level through diverse mechanisms that I mentioned earlier, related to the location and operational characteristics of renewable energy installations, or sourcing and disposal of the materials used. This issue of scale mismatches is going to come later in this presentation. If you look at these trade-offs between increased renewable energy promotion and biodiversity conservation, it is a sort of a green versus green dilemma, in that both of them are legitimate environmental policy targets, but this, in my opinion, these trade-offs are not very well conceptualized currently, and of course comprehensively conceptualized, and they are very context-specific depending on multiple factors, such as the technologies and the social ecological context of renewable energy generation, or even the institutions governing renewable energy and biodiversity conservation. If we start looking at it a little bit more critically, there are very important ramifications related to meeting the post-2020 Global Biodiversity Framework. I'm not going to go in each one of them, but I think critically, there is strong intersections with at least these targets that I have circled. Of course, the trade-offs that I mentioned earlier are essentially threats in biodiversity, okay, either through pollution or land use change or unsustainable harvest, but a lot of the solutions that can be put in place in order to deal with these trade-offs are basically exactly related with multiple of these other targets related in the tools and solution pillar. Unfortunately, I could not separate my presentation by target because there is a lot of overlapping. So what I'm going to be touching are some of the critical aspects that I think are important when we are dealing or trying to put interventions or solutions in order to reduce these trade-offs between renewable energy promotion and biodiversity conservation. So the first one is pretty much straightforward. We have to fill many of the existing knowledge gaps. A lot of the literature at the interface of renewable energy and biodiversity deals with not exactly the impacts on biodiversity, but the drivers of biodiversity change or ecosystem change. So we do not know the exact effects on the different constituents of biodiversity, but we know much more about how the different drivers, how different renewable energy pathways give rise to drivers that affect environmental change. So we need to move beyond studies that explore simply the drivers to the ones that are quantifying the actual impact on biodiversity. We also need empirical studies that adopt full life cycle perspectives or at least focus on poorly understood upstream and downstream activities. And I mentioned mining for the raw material, also the decommissioning. We need also, in my opinion, robust meta-analysis that can consolidate the evidence on the drivers and impacts that is generated and can be helping to assess the magnitude of the different mechanisms and the mediating factors. And we need large-scale modeling exercises and comprehensive environmental impact assessments that explore the effect of different renewable energy scenarios and pathways on biodiversity in especially and temporally explicit manner. There are a lot of studies that are going towards that direction. However, they are not having a very strong, usually they enter through land use change. They are using very aggregate indicators, and it's very difficult to have a rather nuanced picture to understand these kind of effects that renewable energy promotion might have. And I'm going to touch now why this is important for this type of studies. The second thing that we need to do is to improve site selection and installation operational characteristics. One of the things that we have to do is to improve the biodiversity-related aspects of environmental impact assessments for renewable energy projects. We need to clarify first of all, we need to clarify what constitutes significant biodiversity impact for distinct renewable energy pathways and contexts. And we need to promote assessments of cumulative impacts rather than individual one-off projects. Another thing that I think we need to focus is to identify appropriate renewable energy expansion areas through zoning that is informed not only by renewable energy potential, but also by a very good understanding of landscape and seascape characteristics, and especially criteria that reflect the distinct impact mechanisms of each renewable energy option. This is what I mentioned as the major research gap previously. And we need to encourage integrated planning and landscape-based approach that search for a combination of renewable energy sources causing the fewest biodiversity trade-offs. These approaches need to use tools that have a broad acceptability between stakeholders, because a lot of the stakeholders are coming from the renewable energy space or the energy policy space, so there needs to be some sort of common understanding. There is an emerging, very interesting work happening by the Nature Conservancy for both these that I might be able to answer later in comments if somebody is interested. A third pillar that we need to focus is to improve policy coherence. We need to reduce and eliminate misalignment between policies on renewable energy expansion and biodiversity conservation. There is institutional fragmentation, there is also institutional overlapping, and there is certain incoherencies stemming from the fact that different agencies that are often operate at different spatial levels regulate renewable energy and biodiversity conservation. And we need to promote biodiversity mainstreaming in the energy and mining sectors, which is currently far from reality in most countries. Especially this mainstreaming element is a major element discussed through the CBD over the past few years, and is also featuring quite strongly in the post-2020 biodiversity framework. So this is something that renewed effort and further effort would be needed to put properly. And then we need to identify and tackle relevant contentious issues in some national context. For example, I have been working for a few years on issues related to degraded or marginal land used for renewable energy generation that might have high biodiversity value or be important for the livelihoods of local communities. It would be necessary, of course, it will depend on the specific policy topic, obviously, but in these cases, it might be, for example, multi-stakeholder processes that establish commonly agreed definitions about these policy issues, and especially when it comes to marginal land, considering the very different experiences in defining and delineating marginal land in different parts of the world during different periods. The last priority area, in my opinion, is to leverage international processes. We need to capitalize on the reach and visibility of multilateral environmental agreements and related international processes, particularly the CBD and the UNFCCC, to frame the debate and identify contentious aspects and possible responses. As I mentioned, there is a big disjoint between the way that renewable energy is promoted and viewed right now and what might be the biodiversity trade-offs. There is mounting evidence that this thing is happening, okay, but at the same time, we need to identify a common language that bridges national heterogeneity. The differences, there are major differences between technologies and local context and national context, from the institutions to the technologies to whatever else. And of course, there is differentiated capacity between signatories. Okay, and identify possibly joint task forces or joint work programs or knowledge synthesis between MEAs to facilitate the development of this common language, to create a little bit more cohesive understanding of this interface between biodiversity and renewable energy. Some of the final reflections, I'm sorry that I'm going to say some of the things that I already said. It is important to delineate and conceptualize the trade-offs between biodiversity and renewable energy in a comprehensive manner. Right now, it is disjointed. It happens through individual research or individual organizations. I think we need a little bit more cohesive way to see this interface. It is also important to acknowledge the large heterogeneity due to multiple factors, from the technologies to the social ecological context of renewable energy production, to the institutions governing these sectors, to the national sensibilities and priorities when it comes to energy policy and biodiversity conservation. There is a need for coordination between multilateral environmental agreements, whether the CBD, the UNFCCC, but also other relevant MEAs, international processes, to frame these efforts in a cohesive manner, considering this big variability and differentiated capacities of different countries. And ideally, such coordinated action and collective action could ensure that renewable energy expansion, that is a very worthy and necessary goal, does not come at the expense of biodiversity conservation, that is another very important and worthy environmental goal. A lot of the material that I presented now has been published in 2 papers, one in Trends in Ecology and Evolution that came out this month, and this is the more critical aspects of what I presented today, and one that was published 4 years ago in Renewable and Sustainable Energy Reviews, that is a very big, not systematic literature review that tries to identify the different mechanisms through which renewable energy generation intersects, let's say, with biodiversity. That's all. Thank you for your attention. I would be very happy to answer any questions later today or over the next 3 days. Thank you very much.
Thank you very much for very comprehensive presentation. So let me move on to the next speaker. Can I invite Dr. Amanda?
Hi, everyone. Thank you, Saito Sensei, for inviting me to speak here as well. This is based on research I did during my PhD times at the Tokyo Institute of Technology. So basically, I looked at a large part of my PhD was looking at the woody biomass supply chain in Japan, and more specifically, how digital tech can be used to support the supply chain and kind of sustainability across the supply chain. You know, as the previous speaker said, renewable energy and biodiversity go so much hand in hand, especially if we're talking about forests, right? So that's why I think I'm excited to hear the other speakers as well today. Let's see, there's a bit of a lag. Okay, so why woody biomass to begin with? That's not usually something we talk about. We usually talk about solar, we talk about wind, but if we look at the energy, not only electricity, but also energy, including heat and transports. According to the IEA in 2017, modern bioenergy basically took up half of all of the renewables we consumed. So I think it's really a really important part of the conversation, you know, not only talking about solar and wind, but also about bioenergy. And, you know, why Japan? Japan has a huge forest area, which is beautiful, but also very mountainous. But at the same time, even though there are feed-in tariffs for biomass, woody biomass still only takes a few percentages of the power mix. So we did this research to try to see, you know, how might we be able to support, in a sustainable way, of course, more woody biomass in the power mix in Japan. So this is the basic research question. Very simply, how can digital technology support woody biomass in the country? And this is broken down into 2 main objectives. So we want to identify the main challenges of woody biomass in Japan. And we also want to analyze how digital technologies can help overcome these challenges. So all things I say after this are based on papers that have also been published. So if you're interested, please go check it out. So just as an introduction to the first objective, you know, finding out what are the challenges in Japan, just as a background to like woody biomass in Japan itself, it used to be a really big industry. Like in the 60s, domestic wood accounted for about 70% of the share of wood in Japan, but this fell to about 20% in the 2000s. And basically because, you know, this can really compete with the global prices. And Japanese forestry productivity right now is pretty low. And this is because of a mix of challenges that are pretty unique to Japan. So for example, mountainous terrain, fragmented forest ownership, ineffective documentation. And this all really points towards that we need to improve logistics and we need to improve the supply chain of woody biomass from the forest to the end use. And this is really a normal thing for bioenergy, which is so much more dependent on supply chains than things like solar and wind, which basically, you know, you have a wind turbine, you have a solar panel, and then you can produce electricity there. But biomass needs to be processed in so many different ways. So what we did is go to Kyushu, which is the southernmost island of Japan, and talk to different companies. We try to get stakeholders from across the woody biomass supply chain. So we talked to companies that are forest owners, forest industry people, biofuel producers, as well as power and heat producers, in order to understand challenges across the supply chain and not only have, a biased understanding of the power side. And I'm sorry, I'm really speeding through this because I don't have that much time, but here are the results for the challenges. So in the left-hand side, you can see the companies. So company A to company D goes to upstream to downstream supply chain. So company A, again, is a forest owner, and then company D are like power producers, company C are biofuel producers, and so on. And at the top, you can see the 6 challenges or success factors that the people we interviewed really emphasize. So respect of values and traditions, transport infrastructure in the forest, business model integration, relationships and trust, local vitalization, and biomass quality control. So while I won't really have time to go through each of these in detail, but I just want to emphasize what I think is most interesting about this is where the perceptions or kind of perceptions of the challenges diverge across the companies. So in terms of respect of values and traditions, this is something that forest owners really, really heavily emphasize. For example, I think it was company A that was saying that the forest is like his family. It was inherited for many generations. It's something that he wants to handle sustainably. And as he doesn't appreciate when power producers come and say they just want to take all of his wood and burn it up. So basically the forest owners and the forest industry people are very focused on sustainability and respect of the forest itself. And then in the more downstream supply chain, this wasn't really discussed so much at all. But then in terms of biomass quality control, so things like humidity and even the size of the wood chips, this is very much emphasized by the downstream supply chain, so the power producers, et cetera, because this is basically how they make money, by being more efficient in how they produce power and heat. But in the upstream supply chain, we saw kind of a lack of understanding a bit of how to ensure woody biomass control, quality control. So yeah, I think this is really related to, I think, biodiversity as well, especially in terms of values and traditions and local vitalization. Because I think by connecting these stakeholders in a better way, we could kind of have the downstream supply chain people better understand the values and traditions and the need for sustainability in the forest. Because this is definitely some kind of divergence we saw in just how people talked about the woody biomass supply chain. So as a summary of this first part of my presentation, we identified key issues of being the transport infrastructure in the forest to actually take out the wood from the forest, biomass quality, stakeholder respect, relationships and trust, local community revitalization, and just keeping money within the local community. But I just want to emphasize this is really based on local context in Kyushu, in this island, this southern part of Japan. So this will likely be different in different places. But the most important insight is that we did see a convergence and divergence of perceptions, which means that it's so important to understand the whole supply chain of stakeholders, no matter what we're talking about. So now we're talking about woody biomass, and to understand both what people agree on, but also what people don't have the same opinion on. For example, how to handle a forest in a sustainable way. And yeah, we identified both technical and social issues. So everything from biomass quality to just trust and respect of the forest. So this can mean a lot, I think, for supply chain planning. And then to objective 2, which is finding out how can we use digital technologies to help overcome these challenges. Because, as we heard earlier in the keynote, data is the new oil or gold. I think there's different sayings for that. So I think this also applies very, very strongly in energy and in forestry, and also in maintaining biodiversity. So in the forest sector, high quality data is really essential for estimating and approximating biomass. And this is done in different ways now. So for example, field measurements or GIS. But I think in supply chains in general, if we look aside from forestry, Digital capabilities like ICT and cloud are really, really important for knowledge sharing across the supply chain or digital market platforms, because digital technologies can support networked supply chains as opposed to linear, which means that instead of just being in touch with the person or the entity right before or after you in the supply chain, you can understand on a more holistic level what's going on across all the stakeholders in the supply chain. And this means you can make better decisions and business decisions and be more efficient. But this
Amanda,
also needs...
Amanda, could you finish within 3 minutes?
Yeah, that's fine. That's okay. So yeah, basically we found that there's a gap in the woody biomass supply chain and digital tech literature. So you want to try to address that. So we did interviews again. We interviewed 20 experts in the forestry, woody biomass, and digital tech areas. And let me jump to the results. So based on these challenges we identified earlier, we identified how digital technologies can be used to overcome or begin to overcome each of these challenges. And we made kind of visual diagrams for each challenge based on the interviews. So here is an example of a co-location diagram we made for transportation infrastructure and how digital tech might be used to make it overcome that challenge. So for example, you can see here in the top right corner, we have a keyword which was information and share, that's linked to other related words like sharing, 3D, GPS. So basically when we did keywords in context analysis on this, we found that a lot of the interviewees talked about the use of drones and also, of course, satellite imagery to accurately map the forest in order to make better decisions, including where to put roots in the forest in like route optimization strategies. So yeah, I'll definitely won't have time to go through each of these, but I just wanted to show you an overview of how what is in the research paper as well. So we mapped out the challenge, the mechanism, and the technology that might be able to help this challenge. So I already gave you an example of transport, which was the use of drones and AI to better map routes inside the forest, but also in terms of biomass quality and monitoring. For example, the same thing can be used there. I think the use of drones or satellite imagery coupled with AI, a lot of interviewees said that can be really, really helpful to understand if if trees are sick, the moisture content of trees, and when and if they're ready to be harvested. If we're talking about biodiversity or just deforestation, this can also be really, really important, not only for biomass quality and forest quality, but also in terms of bad things happening to the forest. And yeah, so for business model integration, this basically means that the stakeholders understand what other people in the supply chain are doing to better be able to plan their own operations. So again here, if everyone is, for example, a simple thing like a cloud, if everyone is connected on the cloud and can see other people's business operations, this means that they can make better decisions in their own business. And in terms of building trust, I think an interesting example is blockchain here as well. And just to be able to track exactly where the forest, the woody biomass is coming from and make sure it's been handled in a sustainable way and be able to record that in an immutable way on a blockchain. So yeah, I think just the main point here is that concentration can be seen on the use of data, ICT, and sharing information to support value creation in local supply chains. So emphasis again on local. And a lot of interviews were talking about digital market platforms to be able to connect local players with demand for woody biomass or wood products in general in other areas. So yeah, in summary, I think an important insight here is that digital technologies can facilitate many different kinds of mechanisms, from information sharing to transparency to automation, and that these mechanisms in turn can help contribute to alleviate challenges in the supply chain that we identified earlier. But at the same time, whether we're going to use digital tech to support woody biomass or mapping of a forest to understand biodiversity, I think this needs supporting foundations. So participatory planning, change mediation, public funding, for example, until these solutions can be self-sufficient.
Thank you very much, Amanda. Yeah, I think it's well connected with the first speaker's presentation. Thank you very much. So let me invite the third speaker, Sareen, Dr. Sareen. Yeah, floor is yours.
So thanks for the opportunity to speak here. I wanted to use the occasion to take point of departure in a recent collection that I edited on energy infrastructure transitions and environmental governance, which is what I thought of when asked to speak on a theme that relates biodiversity with energy transitions. I work as an associate professor at the University of Stavanger with another position at the University of Bergen, both focused on the governance of energy transitions. So there's a great deal of work out there on that theme. But this particular collection, which was published in Local Environment just earlier this month, brings together what it means to have this massive change in energy infrastructure. And we've seen two sets of very good examples and implications of that shift in the last two speakers' talks. To relate that to another long-standing body of work on environmental governance. So I'll start with the motivation for this, which really came when both the IPCC 2018 report was out and then the IPBES report in 2019. And a group of us asked, when we have so much of the energy sector in a state of flux, and we have expansions in renewable energy as a way to mitigate climate change necessarily on the horizon and actually happening and expanding at unprecedented rates. But at the same time, when we have the persistent grasp of incumbents of fossil fuels and a sector that has typically been driven in a very top-down, historically centralized manner, then what kind of concerns should we really be looking at as social scientists in the energy sector? What are the ways in which this can be not just inclusive and just from a social perspective, but also from a spatial and an environmental perspective, which means considering the impact of these transitions of both sort of the rollout and expansion of renewable energy technologies, but also the phase out of fossil fuel ones in the particular places where they happen, at the scales at which they happen. Do they intersect with other sectors? What kind of implications do they have for biodiversity, for instance, but also for land use, for the particular concerns of the inhabitants of the places in which these infrastructures are changing? So we flagged a couple of key questions. The first is, where does new energy infrastructure appear? How is this decided? And how are the benefits and the burdens allocated from that kind of decision around energy transitions? And secondly, what land uses are displaced with what socio-ecological implications as part of, as essentially an effect of these energy infrastructure transitions? To really inform our inquiry, and a group of about a dozen people working together on this, each with point of departure in our own cases, we look towards environmental and land governance. That's one big set of the literature around natural resource governance, for instance, that we took instruction from. We also were really interested in ethnographic studies on situated social identities. So each of us studied cases that we were familiar with, had spent several years on, and had done detailed field work on in the places where these transitions are actually happening. And also we looked at the field of what we call energy geographies, at emerging conceptualizations of energy infrastructure. So this is something that has really grown, as other speakers have noted, in the past 5-10 years. There's a great deal of work also out of science and technology studies on particular ways of understanding infrastructure in terms of its temporality, in terms of its spatial expanse, in terms of the interactions with existing and changing practices of energy use in society. And a key concern for us was also to think of impact as not just something that occurs at the global or the national scale, Often the conversation around energy transitions gets reduced to international politics, to national policies, but a lot of the changes happen, in fact, at the subnational level, at the regional and urban scales. And this is something that we wanted to bring out explicitly in this work. We also wanted to put some weight to what we often see batted about as an interdisciplinary approach. What does it mean in this instance to be interdisciplinary? What kind of disciplines do we take point of departure in? And I list some of the ones that seemed like natural allies, let's say, but also a couple that might come as a bit more of a surprise. So we looked at political ecology, where a lot of the work on natural resource governance comes from, at human geography that works with people, but also with scales, with interesting concepts of space and place, and at social anthropology, which has a commitment to ethnographic work. But we also considered urban studies for understanding the changes that are happening in cities where, by 2050, we're going to see most of the population live, 70% of the carbon emissions, greenhouse gas emissions are sourced from cities. So this seemed like a relevant place to look. Socio-technical transitions is a bit easier to understand, since whether it's energy infrastructure or, in fact, other kinds of sectoral changes linked with land use, these are socio-technical changes. And finally, epistemic politics, where we tried to problematize our own involvement as scholars, as applied researchers in the issues that we are studying, and what we're doing in the process of feeding out from our work at occasions like this conference, but certainly also beyond the worlds of research and even policy, to the concrete circumstances in which, the concrete context in which these transitions are taking place. Moving on, I wanted to just put out there that this is the introduction. There's several pieces in there. I won't go into detail in this short talk. You're welcome to have a look at the Journal of Local Environment. But what I will say about the collection, and then just to give you a kind of concrete example, is that we have cases from 3 different continents, both in the global south and north, and combined perspectives from established as well as emerging scholars. We also are really happy about having brought together empirical richness here in the case studies with theoretical rigor, with drawing from the multiple disciplines that I mentioned earlier in a way that is closely integrated. To take an example of one of the papers that I was part of, we look at different solar energy transitions in Portugal at 3 different scales, going from a small number of megawatts to several hundred megawatts, and study in detail how solar energy has evolved in Portugal over the past couple of decades, from something that was heavily subsidized to something that has become extremely economically competitive, but also in terms of the contestation in particular cases of solar plants being installed in remote municipalities. We look at the case of Lisbon as a capital that is now leading on ambition and putting in solar plants in its own physical space, and point out that this sort of move is quite essential to avoid a rural-urban dichotomy and a split in terms of where energy is produced and whose interests it's serving, where there's more energy demand. And then we also think in terms of what different scales really mean in terms of the need for transmission infrastructure, for getting energy from where it's produced over to where it's actually consumed, the embodied carbon emissions linked with that. So can we move towards a future where it's possible to have the ways in which solar energy and indeed other renewable energy technologies come up as something that is locally situated, that is responsive to local needs and demands, while also taking along the very ambitious national policies. Portugal has a national energy and climate plan that envisages a growth of solar from what until last year was less than a gigawatt to 10 gigawatts by 2027. So these are massive changes that also imply changes in land use. And just to then begin to wrap up here, I wanted to go back to some of the points I've brought up and give you a few key takeaways from this talk. One is that to meet biodiversity and energy transition targets as captured in the Global Biodiversity Framework and in the Sustainable Development Goals, especially number 7 on universal access to clean energy, but certainly also in SDG 10 on reduced inequalities, the SDG 11 on sustainable cities and communities, for instance, that we need to consider several things simultaneously. Energy infrastructure transitions not as something that happens simply in the energy sector with decisions made by people who are coordinating centrally, but as something that happens in close conjunction with significant changes in land use, and that has to be modulated by, otherwise risks coming into conflict with, situated social identities, the particular lived experiences and embodied contexts of people who inhabit places, their existing relationship with their land. Are they peasants who are used to particular kinds of farming practices? Can, for instance, the solar plants that are coming up use agri-photovoltaic advances that allow these communities to actually generate some of the revenue from the energy transition? Those kinds of concerns. Then the second point is that we must further interdisciplinary knowledge on the social as well as the ecological implications of what we really wanted to flag here are cross-sectoral transitions. So they happen not only in the energy sector, but in sectors such as land, in sectors such as finance, and we see this in energy finance, that's where a lot of the key changes have to happen in order to enable a transition that has just effects and not just one that is led by massive multinational companies that determine the particular shape it takes far away from the places in which it actually impacts the lives of people and the nature outcomes upon implementation. So it has to, this kind of knowledge generation has to take place simultaneously at multiple scales, not only at the national and global, but also at the subnational, the regional, the urban contexts, and indeed the rural contexts where the energy infrastructure is changing. And at the same time, in diverse contexts, the concerns that come up, for instance, in one of the papers in the collection that looks at different solar projects in Australia that take over land inhabited by Aboriginals, by Indigenous communities. Those concerns are quite different than the concerns in a study that looks at several cities in Africa in terms of different fuel uses, in terms of the ability of different communities to have access to and benefits from those particular infrastructure transitions at the urban scale. And those contextual differences must inform our scholarship so that we don't end up with sort of banal, blunt best practices, but rather have policy insights that are fit to purpose, that can drive energy transitions of a sort that contribute to other kinds of positive justice effects in the places where they take place. And finally, energy social sciences really can, as I hope we've shown in this collection, and as I'm happy to discuss in questions further on now, can offer critical insights at this critical intersection of energy infrastructure transitions, changing land use, and situated social identities. With that, I will stop and look forward to a bit of discussion. Thank you.
Thank you very much, Siddharth. So before we have a few minutes for Q&A, but before that, I would like to invite Professor Kazuhiko Takeuchi for his comments. So Professor Takeuchi, yeah, you can start.
Yeah, Osamu, thank you very much for inviting me to this very interesting discussions. And as a person who will have the comments on the three distinguished speakers. First, I would like to say that this is a very interesting issues, how we could try to integrate the renewable energy development with the biodiversity conservation. And this is a very crucial issue because now global community is aiming to achieve 2050 net zero carbon. And coming 10 years will be critical years to take this way. But as you know, that renewable energy development is based on the various natural capital and ecosystem services, and therefore how we could maximize the synergy between the renewable energy development and biodiversity conservation while trying to minimize the trade-off between the two will be the very crucial issues to further we need to develop. I would like to mention as three very important points. As already explained by the Amanda, is a very important issue is biomass usage. And this is one of the key elements of combining the renewable energy with the biodiversity conservation. How we could fully utilize the biomass as a renewable energy sources while trying to conserving the forestry environment and its various ecosystem services will be the very crucial. And the other thing can be emphasized in the other resources, like the issues related with solar energy and agricultural developments, and the wind energy with fisheries. So these sort of things need to be addressed. Because basically, renewable energy is fundamentally decentralized energy sources, different from the fossil fuels, and also the nuclear energy sources. And it depends on the local natural capital and ecosystem services. And therefore, there will be the sort of the overlapping in terms of using of land uses, like forestry, agriculture products, as well as tourism. And therefore, it is extremely important to what I said, that how we could maximize the co-benefit of renewable energy with other use and conserve of the natural capital and the biological and ecosystem services. That will be the very crucial. And second, I would like to emphasize the importance of filling the gap between the use of the renewable energy and the biodiversity conservation in developed countries and in developing countries. And also, I would like to emphasize the importance of filling the gap between the urban areas and rural areas. So developing countries are still immature in developing of the renewable energy sources in harmony with the conservation of the natural capital and the ecosystem services. And therefore, the developed countries need to support the developing countries in order to develop the best way of harmonizing of the use of the renewable energy sources under the condition of conserving of the biodiversity. And also, if you look at the rural areas, renewable energy sources are limited to, for example, to the biomass uses, charcoals and so on. But if we talk about the solar energy uses and many other renewable energy sources, we need to encourage the rural people to introduce the various renewable energy sources so that they could further enhance their livelihood in their areas. And also, it will contribute to solve the issues of the gender and other inequality issues, particularly in the rural areas in the developing countries. So these sort of things need to be further addressed. And third issue is the very important issues that we discussed, how we could integrate the climate discussion with the biodiversity discussions. And previously, all these two issues were separately discussed. So climate change, we have the COP on the climate change, and we have another COP on biodiversity. And one of the constraints that we had was that we could have not enough discussions trying to integrate climate discussion with the biodiversity discussions. And it is extremely important because it is based on the discussion that we discussed about the use of renewable energy sources. It is based on the natural capital and ecosystem services. So we cannot ignore the importance of connecting the climate change discussion with the biodiversity discussion. So how we could consider about the linkage, interlinkages between the two will be a very important issues. And we have the hopefully that this year, the COP on biodiversity in Kunming, and we have the COP on climate change in Glasgow. And it is an extremely important period for us to try to integrate the two issues. Particularly, I would like to emphasize that we are facing with the COVID crisis, and we are now trying to consider about the post-COVID recovery processes need to be combined with the establishment of a sustainable society. So nature-based solution, for example, it is necessary for the climate discussion, and it is also necessary for the biodiversity discussion. And we are now standing on the very important point that we really could combine these two discussions. And this will us to bring another dimension of our global challenges. I hope that this today's discussion will support this sort of the direction that we can move forward. Thank you very much.
Thank you very much, Professor Takeuchi, for very extensive and insightful comments, which should be considered for the future research agenda and also the policy agenda. I think we run out of time and we need to go back to plenary, I think. So are there any secretariat of when we need to go back, or do we have a few minutes?
I think you could take one question perhaps, and then we transition back to plenary, and I will display instruction on how to do that. Thank you, Chair.
Okay. I think that we have one question about Alex's presentation. About regulatory process. I think this is a bit complicated. The another question is about are there any standards to check the sustainable forest management? I think Amanda answered that question. Is it?
It depends on each country, but there's also like the international standards by the Forest Stewardship Council, for example. But I think the problem in Japan is that there's a lack of documentation and like a way to even know what's being planted or not planted. So I think we need standards, but we also need a way to collect the data. If that makes sense. Yeah.
And FSC also has the certification system, which can also consider as a kind of the forest management standard, and also the like a palm oil plantation, the RSP, round table of the sustainable palm oil. They also have their different sustainable standards for the forest management that can be also considered as such kind of example. So thank you very much. So yeah, I think we can close this session. Thank you very much for your all the presenters and also the participant and also the commentator, Professor Takeuchi. So thank you very much.